Well, welcome back. In this screencast, we take a look at one-sided limits. Now, you'll remember that limits considered what happened as we approached a particular x value from either side. So you'd have some function like so, and some value c, and some number here L, and we would say that the limit as x approaches c of f of x is L. As x gets closer and closer to c from either side, the values of the function get closer and closer to L. But what happens if we don't care about what happens from either side, but we only care about what happens from this side, or we only care about what happens from that side? Those limits are one-sided, and I'll demonstrate with this. So this is the function f of x equals square root x squared minus 1. That's 1. That's negative 1. Now, when we talk about what's happening near x equals 1, there's only one way to approach x equals 1. You can only approach x equals 1 as we're coming from positive infinity on the x-axis. We can't approach it from this end. We have to approach it from that end. And the way we say that is that we're going to find the limit as x approaches, I can do this, as x approaches 1 from the right. That's what that plus sign means. It means from the right. So we use the same kind of notation. It's a limit of f of x as x approaches 1 from the right. And we would say that that limit, those y values, are getting closer and closer to 0. Similarly, when we approach negative 1, there's only one way to approach negative 1. We can only approach negative 1 from the left-hand side, from the negative infinity side of the x-axis. So we would say that the limit as x approaches negative 1 from the left, this little, it's a superscript negative sign, just like this is a superscript positive sign. This superscript negative sign means from the left. And the limit of f of x as x approaches negative 1 from the left is also 0. The y values get closer and closer to 0. There's a theorem that's worth mentioning that says the limit as x approaches c of f of x is L if the limit as x approaches c from the left is L, and the limit as x approaches c from the right is L. And this almost makes sense if you think about it. Uh, when we approach c generally, we approach c from either side. So it has to be L as you come from the left. It has to be L as you come from the right. Those have to match, and they have to be L. That almost makes sense if you think about it. So if I may, let's draw a little bit. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So let's draw a function. It's going to have an open circle here. It's going to have a vertical asymptote here. It's going to have like a U-shaped thing here. This is the function g. It's going to have a closed circle here and an open circle here and a closed circle here and be a line. And then it's going to go down to there, and it's going to have a dot here, and it's going to have an open circle here over to a closed circle there, and an open circle here down to a closed circle there. So this is a crazy function, and I want to find the limit as x approaches 1 from the right, and the limit as x approaches 1 from the left, and the limit as x approaches 1. And while we're at it, the limit as x approaches -2. Okay, take a moment, hit the pause button, try those out, make sure that you know what you're doing, and then we'll talk about them in just a few seconds. Don't wait too long. All right. I'm really not waiting that long. Okay, so when we talk about the limit as x approaches 1 from the right, here's x equals 1. When we come at it from the right, we're coming on this branch that leads toward x equals 1 from the right. What's that limit? That limit is 3 because the y value up here, the y values are getting closer and closer to 3. But the limit as x approaches 1 from the left, that's this branch, because this branch is what brings us closer and closer to 1, but from the left-hand side. And those y values are getting closer and closer to 0, which means that the limit of g of x as x approaches 1 does not exist. And it does not exist because the limit from the right and the limit from the left don't agree. Similarly, the limit of g of x as x approaches -2. Well, here's -2. The limit of g of x as x approaches -2 from the left, that's positive infinity. That's going up, 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 up. But as x approaches -2 from the right-hand side, those y values are getting closer and closer to -2. And so this limit does not exist. But I will note that the limit as x approaches -1 is 0 because the limit from the left is 0 and the limit from the right is 0. And I hope that makes sense. We'll do a second video with this lesson that'll talk about continuity, which piggybacks off of this idea, and I hope you stick around for it.